Now this is my third case when gh is equal to k upon s plus 2 upon s square plus 2s plus 4, and I can write this as k upon s plus 2 s plus 1 plus square root of 3j s plus 1 minus square root of 3j. These are my two poles and 1 0. Now I have to plot. My poles are minus 1, this is square root of 3j, and this is square root of 3j minus one pole at this location, one pole at this location. This is my complex pole. In this case, angle of departure exists, and 1 0 at minus 2. Now again I have to find number of root locus branches. Number of root locus branches are given by n is equal to p is equal to 2, which is n, p is my greater than 0, so n is equal to p is equal to 2, z is equal to 1, so p is equal to 2, and number of zeros lies at infinity, which is given by p minus z is equal to 2 minus 1 is equal to 1. 1 0 lies at infinity. Now I have to find my root locus, where root locus branches exist. From this point there is no pole and 0, so my root locus doesn't lie here, and from this point there is sum of pole and 0 is odd, so my root locus lies here. There no root locus at this location, there is no root locus branches exist. So I have to find centroid, real part of pole minus real part of plus real part of second pole minus real part of 0 upon pole minus 0, number of pole minus 0, which is equal to 0 here. Then I have to find the angle. In this case my q value is p minus z minus 1, p is my 2 minus 1 is equal to 0. I have to put q is equal to 0 and find the angle, which is my 180 degree this side. Now 1 plus gh is equal to 0. My k is, from the characteristic equation I have to find break away point, because in this case I have complex poles. K is this, and dk upon ds, put dk upon ds is equal to 0, and I got this two values, s is equal to 0 and s is equal to minus 4. S is equal to 0 doesn't lie on my root locus, and s is equal to minus 4, let it is, this value is minus 4. Here is my break away point. Now I have to find angle of departure and angle of arrival for the complex poles. I have to find the angle for this pole. This pole makes an angle 90 degree, and this 0 makes an angle theta, and this theta value is, this value is square root 3 magnitude, and this value is 1, so tan of theta is equal to square root of 3 divided by 1, and theta is equal to tan inverse square root of 3, and theta is equal to 60 degree for this point. And my angle of departure phi d, which is equal to, for particular pole, which is equal to s is equal to minus 1 plus square root 3j equal to 180 minus phi. Phi is summation of angle of poles minus summation of angle of zeros. Here only one pole is there, so 90 degree minus 60 degree, which is equal to 30 degree. So angle of departure for this pole, s is equal to minus 1 plus square root of 3j is equal to 180 minus 30 is equal to 150 degree positive. And for this pole again I have to find this. Now for this pole I have to find angle of departure. This pole makes an angle 270 degree, because I have to calculate in counterclockwise, and this 0 makes an angle this. For this angle I have to find this angle, and this angle is, this magnitude is square root of 3 this magnitude is 1, so tan of theta is equal to 3 by 1, theta is equal to 60, and this value is 120, and total 0 angle is 180 plus 120 means 300. 0 makes an angle 300 with this pole. So according to the formula, my phi is equal to angle of pole, which is 270 degree, minus angle of 0, which is 300. My phi is minus 30 degree, and phi d is equal to 180 minus phi is equal to 210. This is my angle, and for this pole my angle is from here, it is 90, 80 and 210. Let it is 210. This is my total 210, or in clockwise direction it is minus 50 degree. Okay, this is 150 degree and this is minus 150 degree. So my pole root locus branches goes from here to this point, and from this 150 degree, this is let 150 degree. From here, one pole ends at this 0 and another pole goes towards infinity. This is my root locus for this type of problem.